Alright, welcome back to your favorite trig class, you guys. Today we're going to do law of cosines. This is the law of cosines right here. And they apply to situations where I have a side, an angle, and a side. So side, angle, side. And then a side, side, side. So if I'm given three lengths of a side. That's when you want to use law of cosines. The nice thing, there's no ambiguous case to the law of cosines locally. And so it's pretty straightforward. I do like to give you like where this comes from. Let me. This is one of my favorite proofs of the law of cosine. Let's go ahead and draw a triangle here. Let me drop this altitude down and call this height h. Let me call this angle A, angle B, angle C. So opposite side length B, opposite side length A, opposite side length C. And let me call this length right here x. X is from here to there. That is my x. Okay. And then, so since this whole thing is C right there, this would be C minus x right there. Okay. And so number one, we know by right triangle trig, we know if we took the sine of A, see how we have the right triangle there, it would be the opposite side h over b, right? So in other words, if we multiplied both sides by b, we'd have h equaling b sine of A. Now let's do the same thing for the cosine of A. Similarly, if I took the cosine of A, which is the adjacent side over the hypotenuse, and let's solve for x, and multiply both sides by b, I'd have x equals b cosine of A. And now we know by the Pythagorean theorem, if I take, let me go over here to this right triangle right here. H squared plus that c minus x squared would equal a squared, right, by the Pythagorean theorem. Well, we know by substitution, h is b sine of A. So let me replace h with b sine of A. And then I have a c minus, and then we know x is b cosine A. And this is, by the way, that's lowercase c right there. And let's go ahead and expand this. So b sine A times b sine A is b squared sine squared A. And I got two of these c minus b cosine A's that I'm multiplying out. So I got b squared sine squared A plus c squared minus, I got minus bc cosine A minus another bc cosine A. So that's minus 2 of these bc cosine A's. All right, that's the first was c squared, then minus bc cosine A minus bc cosine, and then a negative b cosine A times a negative b cosine A is a b squared cosine squared A equals a squared. Right? Now look at this b squared sine squared and b squared cosine squared. If I take a b squared out of that, I'd have a sine squared plus a cosine squared. Well, we know sine squared plus cosine squared is 1. And then there's our law of cosines, except they usually will put the a squared on the left. So a squared equals b squared plus c squared minus 2bc cosine of A. Let me go back to our notes here. So that's that one right there. We just proved that one. for the law of cosines. And similarly for those other two, you could also prove those as well. Okay, let's go ahead and use this law of cosines. Notice I have side, angle, and a side. All right, so side, angle, side, or side, side, side. That's when you're going to use the law of cosines. And let's go ahead and label our sides here. So here's lowercase a, opposite angle a. Here's lowercase c. This would be lowercase b. And so we have lowercase a, lowercase b, and capital C. Lowercase a, lowercase b, and capital C. So can you see how this third one would be the one I'd want to use? Because the only unknown would be C, lowercase c, right? And so that's number one. Let's go ahead and pick one of the three, the one that has most variables given. And let's start filling in. So we don't know lowercase c. We do know lowercase a is 2. I know that lowercase b is 3. A is 2, b is 3. And then we know the angle c is 60 degrees. That's capital C, angle c. Right? And so we got c squared equals 4 plus 9 minus 2 times 2 times 3, so minus 12. And then I know cosine of 60 degrees is a half. I looked at on my unit circle. So we got c squared equals 13 minus 6. So c squared equals 7. So it looks like side length c is the square root of 7. Right? So now we know this is the square root of 7. Which is, between 2 and 3, right? It's 2 point something. And so now I want you to note number 2 here. Note that angle B is the largest angle. So, and how do I know that? Well, see how side length B is 3. This one's 2. This is 2 point something. So the side length of 3 is the largest side. So the angle opposite is the largest angle. So you want to, ideally, you find the largest angle because the law of cosines doesn't have two potential solutions like the law of sines does. And so you got to determine if that angle is acute or obtuse, or it's nice to know that if it's acute or obtuse, and the cosine will tell you that, right? And so let's go ahead and find angle B. So I'm going to use the second one. B squared equals A squared plus C squared minus 2AC cosine of B. And this will tell us if angle B is acute or obtuse. Right? So we got 3 squared equals 2 squared plus root 7 squared minus 2 times root 7 cosine of B. So we got 9 equals 4 plus 7 minus 4 root 7 cosine B. 9 equals 11 minus 4 root 7 cosine B. Subtract 11 both sides. I'm trying to isolate that cosine. Right? So I got negative 2 equals negative 4 root 7 cosine B. Let me divide by negative 4 root 7. And so what I have, let me go over here, cosine of B equals negative 2 over 4 root 7. So 2 over 4 root 7, negative over negative is a positive. Of course, 2 over 4 is a half, right? Okay, so I'm right here. Cosine of B equals 1 over 2 root 7. And I can run the arc sine on both sides here. So I run the arc cosine of both sides. And that'll give me angle B. And so now, when I pull up my decimals, make sure you're in degrees if you want this to spit your angle out in degrees. Let's pull up decimals. We're punching in the arc cosine. Again, make sure it's on degrees. See how I can toggle this back and forth. I don't want radians. I want this degrees. And I'm going to find the arc cosine of 1 divided by 2 square root, 2 square root 7. And see how we get, 79.11 in degrees. So that's my angle B. Let me come back here. Write that down. 79.11 degrees. Again, make sure your calculator's in degrees when you do that. So now we have that 79.11 degrees. So the third step is, I don't know angle A, but I do know angle B is 79.11, and I was given angle C is 60 degrees, and all three, of course, add up to 180 degrees. And so angle A, let's see, that ends up being 40.89 degrees, and now we've solved the entire triangle. Okay. Let's do that for this one. Now let's go ahead and label our sides. And notice I'm given side, angle, side, right? So side, angle, side, or side, side, side. That's when you want to use law of cosines. This is a good problem to, you guys try this. So I'm going to pause this for a second, let you guys try it. Before I have you guys pause it, I want to make sure you know you're given lowercase a, lowercase c, and capital B. And so you want to use the one where you have the capital B. You want to use the equation b squared equals a squared plus c squared minus 2ac cosine b. And now go ahead and run that. We don't know lowercase b. We got a, we got c, a, c, and we have cosine 91 degrees. So we got b squared equals 9 plus 4 minus, what's that, 12 cosine 91 degrees. So we got b squared equals 13 minus 12 cosine 91 degrees, right? So that b squared equals, now I'm going to punch this in, and then I got to take the square root of whatever that is. So 13 minus 12 cosine 91, let me put my decimals. 13 minus 12 cosine, again, make sure you're in degrees. Okay, there it is. But I have b squared equals this, 13.21. So I'm going to square root. So I'm going to go square root ANS for the answer, or you could plug, you could just write in, or click on ANS right there as well. So it looks like this is what our b is, 3.63. That's our lowercase b. See, that was 13 point. See, I rounded that to 3.63. All right. Now, I'm going to continue, as long as, if I know my largest angle, as long as I know that, then I can just jump into law of sine. So let's think about who's our largest angle. If this is 3.63, that's the largest side, so it's angle opposite. So B is our largest angle. We already have our largest angle. We know it's obtuse. So as long as you know your largest angle, you can use the law of sines. Right, because you won't have any ambiguity to it to finish out the rest. Because the law of sines is a little quicker, right? So then I'll say, okay, how about sine of B over B equals the sine of A. I don't know capital A over lowercase a, right? again, you just got to make sure that you know the largest angle. Otherwise, you should continue using law of cosines. So sine of A equals whatever number this is. And so we're going to run the arc sine on this. And that'll give us angle A. So the arc sine of 3 sine 91 degrees over 3.63, that'll give us 55.72 degrees. And so our final step 3, we have angle A, we got angle B. We just don't know angle C, but we know they all add up to 180 degrees. And so angle C's got to be 33.28. Okay. All right, let's do one now where we've got side, side, side. You see how we have side, side, and side given. So again, law of cosines. I'm going to start finding the large. Since I can choose, I have lowercase ABC. I can choose which one angle I want to find. You know, in side angle side, I can't choose because I have to find the side length, right? But here I can find the largest angle first, because I could find any of them. Well, the largest angle would be opposite largest side, so it'd be angle C. So I'm going to use C squared equals A squared plus B squared minus 2AB cosine of capital C. And then once I know my largest angle, then I'll know if angle C is obtuse, if it's written as the diagram shows, or if my angle is acute. Right? No ambiguity with law of cosines. Subtract 25 on both sides. So my cosine of C, if I divide both sides by negative 24, is negative 11 over 24. So angle C, now I run the arc cosine on both sides, negative 11 over 24. And my angle C would be 117.28. Again, make sure you're in degrees when you punch in that arc cosine and negative 11 over 24. Again, we know the largest angle, so we can just jump to using the law of sines if we would like. Right, now that we know this is 117.28 degrees. So we can say, well, sine of 117.28 over lowercase c equals, let's do A, sine of A over lowercase a. 4 sine 117.28 equals 6 sine over A. Both sides by 6, so sine and so angle A would be the arc sine of this. So that would give me arc sine 36.34 degrees. Okay, and so now we know we got 36.34. I don't know what angle B is. Angle C is 117.28. They add up to 180, so angle B has got to be 26.38. Alright, let's keep going here. Whoops. All right, this is a good you try it problem, you guys. We've got lowercase a, we got lowercase b, we got lowercase c here, which is 2, alright? So we've got a side, and then it's ideal when the side says, well, it's always ideal. With the log cosines, you make sure that you find the largest angle first. Well, if you notice, this side length and that side length are the same. So that means angle A and angle B are the same. So it really doesn't matter which one you use first. We could go ahead, because A and B are both the largest sides, but they're also equal. So you want to just start by, let's find A. So A squared equals B squared plus C squared minus 2BC cosine of A. And I'm going to let you guys run through that. Go ahead and pause it now. Yeah, A equals B plus C minus 2 times B times C cosine A. Subtract 13 both sides. Divide by -12. Well, -4 over -12 is a positive 1/3. So angle A would be, run the arc cosine on both sides. And that'll give you 70.53 degrees. Now we know here angle A is equal to angle B. So if angle A is 70.53 degrees, then so is angle B. If you want to use law of cosines or law of sines to do that, you could do that too, but more work than is necessary. A plus angle B plus angle C all adds up to 180. So our angle C ends up being 38.94 degrees. Now let's do an application here, the law of cosines. So let's kind of put that diagram in there. But let's go ahead and draw it. We've got a plane that flies due north from Fort Myers. So here's my Fort Myers. It goes due north 150 miles. You see the diagram there. And then it says at a bearing of, so let me draw the little bearing thing. So north 50 degrees east. So at that angle, right, here's my 50 degrees off of the north. And it does this for 100 miles to Orlando, right? So it gets here to Orlando. How far is it from Fort Myers to Orlando? That's question 1. So how far is that? And question 2, they'll ask us, what bearing should they take? So if this is a bearing from Fort Myers, it's north such and such degrees east, right? So we're also looking for that angle right there. So let's go ahead and just label our diagram. Here's Fort Myers. There's Orlando. And let's start working this problem. Here's lowercase b. That's the first thing I want to find. I have lowercase a, I have lowercase c. And number 1, do you see how this is a supplementary angle? Since we know that's 50 degrees, so 50 degrees plus that angle B, those add up to 180 degrees on that straight line there. So we know angle B is 130 degrees. That's helpful, right? Because then we can solve for lowercase b because we have capital B. So we're going to use the second one on the log cosines. B squared equals a squared plus c squared minus 2ac cosine of b. B we don't know. A we know is 100. It's 150. Oops, that's supposed to be squared, not a degree. And cosine of 130 degrees. And so let me pull up my decimals. I'll punch in 100 squared. That's, what is that, 10,000? 150 squared. And minus, okay, so we end up with 51783.62829 for all this. And then we'll square root. So B ends up being 227.56 miles. So that's how far it is from Fort Myers to Orlando, right? 227.56 miles. And then part B on this says, well, what bearing should we take, right? If we're right here at Fort Myers, it's going to be north, whatever angle A is in degrees east, right? We just need to know angle A, whatever that is. So that's what we're trying to answer on part B. What is angle A? And so what we'll do on this, we have A, B, and C now, so we can go A squared equals B squared plus C squared minus 2BC cosine of angle A. Remember, we're trying to find angle A. Lowercase a is 100 squared. That's the 100 right here. We know C is 150, and then of course we just solve for B, 227.56. And multiply 2 times 227.56 times 150. Let me add these two and then subtract them from 10,000 and divide them by negative 68268. And so angle A would be the arc cosine of that. Make sure you're in degrees. So we want to go north 19.67 degrees east. That's the bearing to get back, to go from Fort Myers to Orlando. And thanks so much for taking notes. See you guys next time.